So we've been doing, we did last lesson regression analysis. So we went through the whole process of where we, we built the scatter plot and then went and did, found the equation of the line. So we looked at that, and then we also looked at the residual plot, which was a test to assume, we assume it's linear. So when we create that line, so that y equals a plus bx, we assume it's linear. And then we did the residual plot, was the test to confirm whether it is or isn't linear. So just this next part is we need to know. So we've got a scatter plot here, given here. So you can see we've been given two numerical variables. So they measured people's ankle circumference and they also measured their wrist circumference. So here would be a way you wouldn't be able to tell which is RV, which is EV if you were just given the list. So here we can tell the wrist circumference is RV because it's on the Y part of the axis, and we can tell ankle circumference is the EV. So we need to find, when we've got to find the equation. So they've done all that and they've actually drawn the equation line on the graph there. And what they'll ask you to find it. So you can see I've found it, it's been written down here. So the way you do that is when you've got given the scatter plot and you're given that line and you want to find the equation of that line. So to find any straight line, you need to use 2 points that the line is going through. So use 2 points the line's going through. So we'll do that. Going through. So what we're going to do is we're going to have a look at this scatter plot. Sorry, I've just put it on the next page and I'm going to blow it up. Just going back to this one. So if we go to do, so if I went to go find the equation of this line, so they've given me the graph, I'm going to put 2 points in. Once again, you can see that is not the y-intercept. So this point up here was 1092. You can see I've popped that in the calculator and I've used the last one, the 24, and it looked like 32 or whatever. And I did it again, and all I've got to make sure, what you need to make sure and what they're really testing you for is that you're writing the right variable names when you write it out. So you're putting humidity here and you're putting temperature there. And obviously you get the values, but also that you're maybe using the right significant figures and things like that. That's what we're testing. We're not testing you, can you find the gradient of a straight line we don't really want to know that gradient formula. All right, so we have this scatter plot and we're going to get 2 points off it. So what you've got to do is be careful. If you look down here, you can see that this says along the x-axis, that's 21. So what they're not actually, so this is not actually the y-intercept there. It's just showing you a part of the graph. The y, if it was the y-axis, that down there would be 0. So it's not. Be really careful. So because that is not 0, you definitely know that this value here mustn't be the y-intercept, okay? It's definitely not the y-intercept. So you can sometimes use that to help you answer a question. You can eliminate that must not definitely be the y-intercept. So anyway, we're going to try and get the whole equation. So we're going to use 2 points that this line is going through. So I'm going to use this first point because it is crossing like it's a nice on the line. So I'm going to say when x is 21, because this is the x-axis, I'm going to say that y is 17.1234. I'm going to say y is 17.4. So I've read off here. And the other one I'm going to use where it crosses up the top here. So I'm going to say when x is 26, and I'm just using them because I think it's easier. It's just pick easy ones that you can see. So it doesn't matter which point on the line you pick, just as long as it is on the line. So I went up and I looked, I've used my ruler and I can see that that's like 19.1. So here's my 2 points, okay? So what you're going to do is you're going to pretend like that's your list. So if you had a table of values, so we would say, well, we'll even call it what they've called it. What was our EV? So wrist was our RV and ankle. Okay, so we're just going to use those 2 points we've got, and we're going to pop them in a listen spreadsheet. So I see you got 21 and 17.4, that was the first point, and 26 and 19.1. Just so we can quickly get the equation, we just use those 2 points, and you do what you've always been doing. So you do the linreg, so where you press menu, stats, so you're here, and you press menu, stats, stat calc, then linreg A plus BX. And then you just choose your X list. So whatever you called it, if you called it the right way, you might say X list was the ankle and Y list was the wrist. So you can see here we got the A and the B values, and therefore we wrote out our formula. We could find the equation and we could write it out here. So there's my A and there's my B. Okay, that is the quickest way to do it, because I know some of you have the, you can use the gradient formula where you have, where y2 minus y1, you could do that, but it's going to be a lot of calculations. We are not testing that. So use your calculator and eliminate doing little calculations, because we accidentally make little mistakes. So just go with this. You're going to use this. You're already used to using lists and spreadsheets, so it's the quickest, easy way, and you don't have to learn anything new. You just pretend you've got a little list and you're getting the line of that list. All right, so so we're going to do this exam question regression analysis thing. So it says question 3, the data in the table below shows a sample of actual temperatures and apparent temperatures recorded at a weather station. A scatter plot of the data is shown. So what we're looking at, when they do give us the scatter plot, we should be looking here and saying, all right, apparent temperature is definitely the RV because they've put it there. And then this one must be EV. Now, you need to be really careful, because apparent temperature, actual temperature, they sound similar, they look similar, so your mind will get confused. So just be really careful. So we've put in there, now it says use the scatter plot to describe the association between apparent temperature and actual temperature in terms of strength, direction, and form. So we've popped our list in anyway. So in reading time during the exam, you would have noticed and read ahead, you have a whole heap of questions on this data. You would be needing to type it in anyway. So you've typed it in, and the strength is going to be the R value. Okay, so we've put the list in our calculator, and we've done the statistics, and we've got, because we need to comment on the strength, so the strength is the R value, and we found the R value to be 0.98, so that's a strong, isn't it? And the direction is positive, and what's the form? Looking at the graph, what do we think? So we're going to say it's a strong, positive, and what do we think the form is? Yeah, linear. So it looks fairly linear, doesn't it? It doesn't have some pattern. It's going up, so we're going to say linear. Now, it says determine the equation of the least squares line. So what that means, that is you've got to find the A and the B value, which are over here. We can see that. Now, also, always when they ask for the equation, they're going to be asking for, say, either decimal points. Often, it's significant figures when we're doing the equation. So let's look. They want 2 significant figures for these 2 numbers. So you can see the first one. We've got to look at the third number, and because that's a 5, that 6 needs to go up. So A is negative 1.7, and then we look at the B. We want 2 significant figures, so we look at the third there, and because it's only a 2, that number next to it doesn't have to go up, so it's 0.94 times the actual temperature. Moving on to the next part, it says interpret the intercept of the least squares line of the thing. So the intercept, So A equaled negative 1.7. That's the intercept. This is where you're going to use this notes. Remember, it was in our regression analysis notes. And this is where we would write this out using this statement. So I'm going to interpret it. I'm going to say, it says interpret it. We'll just say the intercept predicts and it was apparent temperature. Yeah? Apparent temperature to be negative 1.7 when the actual temperature, so that was the EV, is 0 degrees Celsius or whatever. Okay? So I might put Celsius up there too. Okay, so I'm just using this statement here that I've gone to my notes and I've found it. And then the next one has asked me to interpret the coefficient of determination. So that's the R squared. So I've gone to my notes for that because I told you every time you see the word interpret, there will be a fill in the blanks. So here we go. So I'm going to do that one. So the coefficient, now they told me it to be 0.97. So the coefficient of determination tells us that, now I'm going to change the R squared to a percentage. So they've said it was 0.97, so that's 97%. So I'm going to say that 97% of the variation in, and we've got to say apparent temperature, is explained by the variation in, what was it? Actual temperature. Okay, so I'm just filling in the blanks. So there you go. Then the next part. They said a residual plot was obtained, so they did it for you, and they said in the shown. So a residual plot can be used to test an assumption about the nature of an association between two numericals. What is that assumption? What do I say we're assuming at the start when we're doing all this? We're assuming it is? Yeah, so you're making an assumption. You can just say it's linear. Okay, now does the residual plot support the assumption? And we're going to say yes, because it looks like random scatter. Yeah? So I'm going to say yes, as the residual plot shows no clear pattern, therefore suggesting the data is linear. Okay? So the scatter plot below shows life expectancy years plotted against human development index in a large countries. The least squares has been fitted and the resulting residual. So this is the original scatter plot and this one is the residual plot. Okay, and now they've given you some more information. They've said they've given you the equation here and they've given you R squared. Given the information above, which of the following statements is not true? So the value of the correlation coefficient is 0.94. So that's the R value. So we're looking for not true. So if I need to find the R value, I'm going to have to do the square root of 87.5. And I'm then going to have to also decide whether it's plus or minus. Now, because this graph is a positive, it's going to be a plus number. And what's the square root? Is it 0.97? Is that correct? Oh, what did they say? 0.94, sorry. It is. So this is true. So this is true. So we're happy with that. So R ended up equaling 0.94. So it says 12.5% of the variation in life expectancy is not explained. So variation is when they're talking about R squared, okay? So if I look up here, R squared, remember we would say 87.5% is explained. So if you do 100 minus 87.5, do you get 12.5? You do, don't you? So 12.5 is not explained if 87 is. So this statement is true as well. Now, the next one where it says on average, so when they talk about on average, they're talking about the B value. So on average, life expectancy increases by 43. Is 43 the B value? Up there? Increases by 43. No, what's 43 up here? It's the A value, isn't it? So if I said on average it increases by, you should see the gradient written there, whatever the B value is, and it's not. So this one I'm going with is not true. So I'm saying that's my answer. So then if I go and check the other ones, hopefully we will see that they're true. So it says D, ignoring any outliers, the association between life expectancy and a human development index can be described as strong positive linear. That's true, because we can see there's maybe a few outliers, but the residual plot's showing random, so it helps us say yes, it's linear, so that's true. And using the least squares line to predict life expectancy in a country with the human development of 75 is interpolation. Well, that's true, because 75 is within the data, so that is true as well. So this question 10, in 2011, life expectancy in Australia was 81.8 years and the human development index was 92.9. So they just gave me a Y then when X equaled 92.9. Now, they said when the least squares line is used to predict life expectancy, the residual is. So as soon as you see the word, you've got to find the residual, you should be writing out that formula. So you go residual equals actual minus predicted. So actual is either given to you, or you can see it as a dot, or you can see it in the table of values. Because this was a little bit everywhere, they've actually given it to me. They said life expectancy was 81, so they told me it was 81.8, and then I have to find the predicted. So the predicted is you use that equation which they gave you up the top. So I'm going to use 43.0 plus 0.422 times, and they've told me which X it was 92.9, and you're going to get a residual value. So I end up with negative 0.40. So they've got, I'm going to go with B. Okay.